So our last section that we're going to look at for exponential functions is solving exponential functions, which means that your test is going to be next class. Yay! Fun. So you'll have the option of either studying during the period and taking the test home, or taking the test during the period if you don't feel like you need to study. Your choice. When we're solving exponential functions, the most important part is the base. We've got to get the bases to be the same, and then we can solve. If we can't get the bases to be the same, at this point you're going to tell me that you can't solve it because the bases aren't the same. So it's all about the base. We've got to get the base to be the same in order for us to be able to solve these. So you saw some of these the other day when we were playing that game. Write 64 in base 8. So how can I rewrite 64 to be 8 to some exponent? 8 squared, right? I can just remake it as 8 squared because 8 times 8 gives me 64. What about if I wanted to rewrite 64 in base 4? 4 to the third, right? I need 3 4s. If I wasn't sure, one, I could whip out my calculator, right, and see how many times I have to multiply 4 until I get 64. If I didn't have a calculator, I could say, oh, I know 64 is 8 times 8, right? And I know that 8 is 4 times 2, and 4 times 2. So I have 1, 2, 3 4s, right? Because the 2, if I put the 2's back together, that's really 4. So you could always break it down and see how many pieces you have in there, or how many ways you can make 4. So I can rewrite this as 4 to the third. What about 27 base 3? 3 to the third, right? 3 to the third. So we're seeing that we can change numbers to be different bases. What about 27 base 9? Yeah, it was our challenge problem in the game, right? Well, let's see. We know 27 is 9 and 3, right? And 9 is really 3 times 3. So if we're talking about 9s, I have one full 9 here, and this counts as half of a 9. So I could really say it's 9 to the 1.5, or if I like fractions better, I could say it's 9 to the 3 halves. Either way, because I have one full 9 in 27, and then I have half of a 9, so 1 1/2, or 3 halves. So basically, we have this big fancy property. It's called the property of equality of exponential functions. It's a big fancy math way for us to say, if the bases are the same, the exponents have to be the same. So it's our big fancy way of saying, if the bases are equal, then the exponents have to be equal. And you saw this a little bit in our game too, because it was things like, if I said to you, we have 3 to the 5th equals 3 to the x. The only way those are going to be the same is if x is 5, right? Because I can't say 3 to the 5th is the same thing as 3 to the 4th, because those are different numbers. They're not equal, right? In order for them to be equal, their exponents have to be equal. So if we can get the bases to be the same, then the exponents have to be the same, and it allows us to solve these exponential functions. So if we are going to solve these exponential functions, the first thing we want to do is get the bases to be the same. So step 1, get the bases to be the same. Normally this means look at the bigger number and try to rewrite it in terms of the smaller number. So if you had a 64 and you had an 8, you want to rewrite 64 to be in base 8. So you normally want to look to change the bigger number. Look to change the bigger base first. Sometimes you might have to change both bases, and we're going to look at examples of both, but normally you want to first check your bigger base and see if you can rewrite it to match the other given base. After we change the bases to be the same, then we can cancel the bases and set the exponents equal to each other. Cancel the bases and set exponents equal. And then we're just going to solve. Because at this point, once we get the exponents, once we cancel the bases and set the exponents equal, we're going to be left with equations that we already know how to solve. So we're just going to solve. So let's look at the first one. Solve 12 equals 12 to the x. Our bases are already the same, right? So since our bases are already the same, I can just cancel the bases out, and I'm really left with an exponent here that's 1, and just set my exponents equal to each other. So now I just have 1 equals x. X is by itself. I don't really need to solve anything. It's already done for me. So for some reason, that one always panics everyone because they overthink it. And it is really that straightforward. Once the bases are the same, they can go away. And we just want to know that the exponents are equal to each other and solve the exponents. Because if the bases are the same, that property tells us that the exponents have to be equal. So we're just setting the exponents equal and solving. So if we look at the second one, if we look at B, where we have 8x minus 3 equals 8 to the 4th, first thing we check is our base is the same, and they are. They're both 8. So we can cancel the 8's out, and we're left with x minus 3 equals 4. Solving a one-step equation just brings us sweet joy, right? We add the 3 to both sides, and we get x equals 7. All right. I got 2 takers that would like to earn some tickets. All right. All right, you got the other one. Oh, payment's already up. agree with the answers on the board? So the first one, we can cancel those 100s, and we just get that 6 equals x, right? The second one, we cancel the 5s. We get 2x equals 3, divide by 2, and we get x equals 3/2. What if we spice it up a notch and the bases aren't the same? So now we have a is 5 to the x equals 25. And b, 27 equals 3x to the 4th. So I've got to change the bases, right? I've got to change the bases for these because they're not the same. So I want to always look at the bigger number first. 25 is definitely bigger than 5. So I want to check the bigger number and see if I can rewrite it as 5 to some power. Which I can, right? I can rewrite it to be 5 squared. So I'm going to do that. I'm going to keep everything else exactly the same. And now my bases match, so I can just cancel my 5s, and I get x equals 2. So now I want to do the same thing with b. I want to look at 27 equals 3 to the 4x and say, okay, 27 is my bigger number. Can I rewrite 27 as 3 to some power? And we know we can rewrite it as 3 to the 3rd power. We're going to keep it, the rest of it, all the same. Just bring it down. So now my bases match. I can cancel out my bases. I'm left with 3 equals 4x. So I divide both sides by 4. And I get 3/4 equals x. So I have 2 more takers who would like to get paid. Go ahead. Yeah. Huh? Where's your notebook?
In the classroom.
Oh.
Like double points.
You gotta get your bases to be the same. You want to do like half that? You're at that. You're on that. You gotta change the 64 to you.
Oh, yeah. No. We need to.
Change this. I can just write
Oh.
64.
Oh, wow. Is that a guy? Hmm? He's about to use addition. Where's somebody out? Would you be able to do this? It's like on this marker is broken. Could you do this by doing like?
Would I be able to do this? By like, no, I guess no. I'll be right.
So I gotta change the bases, right?
I was gonna say, could you subtract 60, but I realized if you subtract 60 from here, you
They have to
subtract.
write over there.
Wait.
You gotta change your bases. So the first one, you rewrite 64 as 4 to the third. Bring the rest down. X plus 1 equals 3. You get x equals 2. 64 is the same thing as 8 squared. So you get 2 equals 2 to the
Can
x,
you do this like this? Is this number?
5 by 2.
Oh, you're right. Could you do this like this? I subtracted 60 from this side and subtracted 50. And then
You can always, as long as you do the same thing to both sides, you can always do it. But by subtracting 60, now you've made that left side way more complicated to solve. Because now how are you going to get x by itself now? So you haven't done anything illegal. You've done the same thing to both sides, which you can always do, but you've just made life more complicated for yourself
Okay.
by doing that. While you're up there, you want to erase the board for me too? Thank you, sir.
I'm trying.
What if I take it to the next level? Where it's 9 to the 3y equals 27.
AJ's doing the next problem.
Oh, I didn't get my payment. My payment. I couldn't get it when I do that problem.
9 to the 3y equals 27. So first I look at 27, and I say, I could rewrite 27 to be 9 to the 1/2 if I want 1.5, right? If I wanted to. But I also recognize that 9 and 27, I could change both of them to use 3's. So sometimes we might need to change both of them. If you like trying to figure out the fraction exponent and you want to do that, you would still get the same answer. So if you did want to rewrite 27 as 9 to the 3/2 and solve from there, you would get the same answer. But I would rather work with whole numbers if I can. So I'm going to go in and I'm going to change 27 to be 3 to the third. And I'm going to change 9 to be 3 squared. Now when I change 9, since 9 already has an exponent, I put this 9 in parentheses and I keep the parentheses only with the 9 inside. So this 3y is going to stay on the outside of the parentheses. So I always kind of protect what I'm changing so that I don't accidentally mishmash the exponents together. Because now, instead of having 9 to the 3y, I'm going to have 3 squared to the 3y. So I always kind of protect it with my parentheses. I rewrite 9 to be 3 squared. And this is why we were practicing those exponent rules in your do now, because now I need to know, what do I do with 3 squared to the 3y? What do I do with those exponents when it's a power to a power? I multiply them, right? So I really have 3 to the 6y equals 3 cubed. Now my bases are the same. I can cancel them. I get 6y equals 3. I divide by 6. And I get y equals 1/2. So I want to do the same thing for b. I've got 32 equals 4 to the x minus 3. So I want to work with a base that will work for both of them. So in this situation, once I look at 32 and I say, oh, 32 isn't 4 to some power nicely, Then I kind of look at the smaller one and I say, okay, what can I rewrite the smaller one as? Because it might be easier for me to pick out a common base from the smaller one because I'm going to have less options with the smaller one. So I look at 4 and I'm like, oh, well, 4 is 2 squared, right? And I can get 32 from 2. So let's use 2 as our common base. So first, I'm going to rewrite 32 is the same thing as 2 to what power? Well, 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16. 16 times 2 gives me 32. So 5. 2 to the 5th. Bring down my equals. Now I've got to change my 4, so I'm going to drop in those parentheses so I can protect it. 4 is really 2 squared. Bring down my x minus 3. Now I know I've got to multiply these exponents, so basically what I'm doing here when I multiply is I have to distribute to both of these. So I really have 2 to the 5th equals 2 to the 2x minus 6. And then I can cancel my bases. And I get 5 equals 2x minus 6. So I add 6 to both sides, right? And I get 11 equals 2x. And then I divide by 2. And I get x equals 11 halves. Or 5 1/2. So having to change both bases is as tricky as it's going to get today. Okay. Do you want to try 2 and get paid for them? Or do you want to start your classwork? Start your classwork.